All right, this is lesson 2.3, solving equations using distribution. This first page is just a warm-up of kind of all the stuff that we've done. So you're going to have evaluating expressions as your first couple of problems, first three, which is going to involve your sign numbers and your order of operations. And then 4 through 7 is going to be solving equations. You're going to do your flipping, combining, and dividing. All right, so I'm going to go ahead and start with the first one here, x, y plus z. Well, x and y are next to each other, so I'm going to put parentheses around them. So we'll put a 2 and a -3. And then plus z, which is 5. I don't really need a parenthesis around that one. And now we're going to do our order of operations. Parentheses, exponents, multiplication, division from left to right, and addition, subtraction from left to right. So there's nothing to do in the parentheses, and there are no exponents, so we're going left to right, multiplication, division. So as we come right here, we can see parentheses next to each other. That is multiplication. 2 times 3 is 6. I only see one negative, so there's nothing to cancel. So that's going to be a -6 plus 5. And then here we have a war. Negatives win. 1 left over. And just like with the other warm-ups, I should have started with this, I apologize, but you should be working the problem, pause the video, work the problem, and then watch the answer to see how you're doing. And see if you have questions you'd like me to go over with you, or if you need more practice, anything like that. So use this as a learning opportunity to get feedback on how you're doing with the content. All right, let's go to the next one. So for this problem here, x is 2, so I'm going to put a 2 out front. Parenthesis, y is -3. Now in this case, I don't have to put the y, the -3, in a parenthesis, because it's already got a parenthesis here that's separating it, and then the z comes after, plus 5. If I rewrote this as 2 and I put -3 in its own parenthesis, it doesn't really change the math. You're still going to be fighting this war in either case. So in this case, the parenthesis is optional. So if you're ever not sure whether it's optional or not, you can put it in there and see, does it change the math? If it doesn't change the math, whether it's there or not, then you don't need to put it in. All right, let's do what's in the parentheses first. This is a war. Positives win. There'll be 2 positives left over. And now we have multiplication. 2 times 2 is 4. Next problem, z squared minus y. Z is 5, so it's going to be 5 squared minus the value of y is -3. So this is where I think a parenthesis is helpful, because this way you know that this negative came from -3 and this minus sign came from the equation. So a lot of times I'll have students just put one of those, and the parenthesis kind of reminds you that, oh, this negative was attached to the input, and that was already a negative. All right, so what do we do first? Parentheses, well, there's nothing to do here or here. Exponent, there is an exponent. 5 squared is 5 times 5. So that'll be 25 minus -3. For our next step, I'm noticing that there is a double negative there. We're going to have to resolve that. So a double negative is a positive. So it becomes 25 plus 3, which is 28. All right, so those are our evaluating expressions problems. Let's move on to the solving equations. So for this one here, we're going to do flipping, combining, and dividing. Here, I'm going to take the -2 and flip it. So bring down my equal sign, write down my 7, and then -2 flips and becomes +2. We still have a 3x left on this side. Then we'll be combining. That is a war. an alliance. It's both positives. That makes a 9. Bring down our 3x, and then our last step, divide both sides by 3. All right, and once again, when you work these problems, plug them back in with your calculator. Check to make sure you're right. If you're doing a quiz or a test, you can know whether your answers are right before you ever turn that in. So I do recommend that as a habit. So let's take a look at this problem. Here I have 6, 1, -2, and a +5. Bring down my equal sign. I can do flipping first. I could do some combining. I actually think I am going to... There's a lot of approaches here. I could flip the 1 and the 5. I could flip those to this side and leave that here. I could flip this over and flip that over. It's the same number of flips either way. I'm going to work it both ways. So let's say I decide I'm going to take the numbers and put them all on this side. So we still have the 6. The 1 flips over. It becomes -1. Well, if I put a -1, I need something here. Now, the 6, I didn't need anything in front of it because it was the only thing here. But as soon as I flip a number in front of it, I have to declare its sign. It's +6. And same thing with the 5. I'm going to flip that, and that becomes -5. That leaves me with -2n. So don't forget, this negative is still there. It wasn't attached to the 1. That's a +1 and a +5. They became negatives. But -2n never moved. It just stayed negative. Now let's combine. -5 plus -1, that's a -6 and a 6. All that combines to 0. And then our last step is divide. Divide by -2. That will reduce to just an n. And 0 divided by -2. Now remember, you're asking, if you think about kids and cookies, the top number is the number of cookies, the bottom number is the number of kids. You don't have any cookies to give. So everyone gets 0. So 0 is a valid answer. That's fine. Now, what if we chose to do this a different way? And this is probably the way I would have done it. Because the only thing you kind of run into with this one is you do have to deal with that -2. And a lot of times I see people forget the negative. But what if I just took the -2n and I flipped that over and it became +2n? And I took the 6 and I flipped it over and it became -6. So you still have your 1 and your 5, but now you have -6. This is still 0, and you would still divide by 2 and get 0. All right, next problem. I want x's on one side and the ones without x's on the other. So this 8x is great where it is, but I want this 7x on the same side. So 7x flips and becomes -7x. Bring down the equal sign. This -9 is fine where it is, but I do need to take this -2 and flip it over. It becomes +2. Here we have a war. Positives win by 1, so we're just left with 1x. You don't have to write the 1. And then we have a war here. Negatives win. There'll be 7 negatives left over. So -7 is that answer. Once again, plug that -7 into this side and then do the same thing on this side. See if you get the same value. If you do, then you know you did it right. All right, let's take a look at the last one here. I'm going to do the same thing. I'm going to take the -5a and flip it. So this a stays here. And this -5a flips and becomes a +5a. This 5 doesn't have an a, so we need to flip it over here. It becomes a -5. This 5 is still here, and that becomes a -5. Oh, we get a 0 again. What about this? A plus 5a. Remember, this is one rectangular tile and then 5 more rectangular tiles. So just because the 1 isn't written, that's a 1a. So if you add that, you do get 6a. Divide both sides by 6, and you get a equals 0. So once again, we got 0 as an answer. That's fine. That can certainly happen. All right, so that is the warm-up problems. On the other side, we're going to talk about the distributive properties. So please continue on to video 2.